Top boss, today we are at our customers' residence. There are a lot of issues here, like you can see. First, before troubleshooting, I opened the consumer unit area, and what I found was shocking. These MCBs could not trip simply because they are concealed. But the first reason why she called us is because she was receiving an electric shock from this cooker. We inspected the cooker and discovered that there were issues because the earthing connection was not properly done. The connection to the wire was done on the insulation. That could definitely compromise on the path of safety. So we had to sort that one out. But there were still so many problems in this home. For instance, my top boss, this is a cooker unit. It is a circuit that is supposed to supply power to the cooker. The cooker is supposed to be very independent, but there are terminations from this cooker unit to feed another socket in the kitchen. That means the same circuit has been overloaded. Now we have identified that there is a problem with the meter box. The earthing is not properly done. Even at this point here, we don't have the earth connection. The earth connection is supposed to protect the customer. My top boss, today we are at our customers' residence and we are here to check the issue with safety. There is a problem with earthing. We have confirmed that the meter box is not properly wired and also the earth rod is missing. Customer is not protected. So that is what we are here for. Even to begin with, you notice that there is a lot of mistakes on this meter box. This is the entrance of electricity to the customer. Look at the connection. What is your take on this, top boss? Let me know in the comment section what are some of the faults that you have identified in this meter box. You will notice that there is a lot of issues and the genesis of the problems is here. Isn't an earth pit supposed to have an earth rod, right? But we don't have it here. What do we have? Just connections that we are not sure about. We will be updating you on the faults that we have found and the advice that we give to our dear customer so that if implemented, they will be safe together with their loved ones. So come with us as we go to the house. So first and foremost, we switched off power and we noticed a lot of errors here as well. Look at that consumer unit, my top boss. I believe that the sole purpose of a consumer unit is to house the protective devices. The protective devices are supposed to trip in case of a fault. This will not enable any tripping of the circuit breaker. That is so serious. Just to be sure that we had switched off power, we tested with a non-contact tester to ensure that we are safe to operate on it. This cover here was connected like this, meaning the circuit breakers were blocked from tripping. The main purpose of a circuit breaker or an MCB is to trip in case the specific circuit is faulty. Having these connected this way, it means that they cannot trip. So now we have identified that the installation was poorly done upside down. So the only option is to also return the cover in an upside down manner so that the MCBs can have space to safely trip in case of a fault. Electricians in Kenya are surely joking. We have connected this RCCB so that we can test whether each and every circuit will trip in case there is a fault. Having ruled out any possibility of an electric shock coming from the appliances or the internal wiring, we shifted our attention to the meter box, the earth pit, as well as the earthing that has been done to this house. There is a problem with earthing. We have confirmed that the meter box is not properly wired and also the earth rod is missing. So if the earth rod is not there, it means that the customer is not safe. My top boss, to demonstrate using a diagram here, we have a powerhouse somewhere. We were not able to see it, But assuming that this is the powerhouse in question, we have a cable all the way to the earth rod. And we have the three-phase cable traveling all the way from the powerhouse, very long distance, if you ask me, for this size of a cable. Because remember, we discovered that the size of the cable was too small. One of the contributing factors when it comes to the resistance of a cable is the length. We learned that in high school physics, that some of the factors that affect the conductivity of a wire is, number one, the distance. So the longer the wire or the longer the cable, that definitely dictates the resistance. So it means that that cable size was too small, according to my observation anyway. Now, the cable travels all the way to a point here serving several customers. There's a problem, a huge problem, because this termination is happening at this point and it is the lowest point. And in case there is water seeping through this box, there could be a problem. As you notice from this demonstration, the termination was insulated. The insulation was done using an insulation tape. Now, an insulating tape in this case is not advisable because, number one, loose connections. Electrical joints have to be tight, especially where several customers are connected. Customers in this sense, each and every house, remember, has an instant shower, that is a heater, has an electric cooker, that is a heater. These are heavy loads. Remember, the customers are also expected to connect their appliances such as room heaters or even AC. This definitely draw a lot of current. In my opinion, the termination that was done here is illegal, is very poor, is not electrically and mechanically sound. That predisposes the customers to a lot of issues. And if you can see from the photo that we have here or the video, is that this insulation tape is already compromised. A lot of heating, a lot of melting, and the customer was definitely complaining that they could detect a burning smell from this point, sometimes even smoke, that was caused by loose connection. Now, just to point something that is very important and why the customer called us, the customer was receiving an electric shock from the electric cooker. My top boss, if you are finding value out of our today's video, kindly smash that like button. And also, from your expertise, what are some of the mistakes that you have identified on this installation right here? Let me know in the comment section, my top boss. And another important thing, let me know where you're watching us from, and we'll be so glad to interact with you. My top boss, we were able to discover one important thing about this setup, that the earthing is compromised. Instead of having each and every unit supplied with its own earthing, that means an earth pit, an earth rod, we discovered that there was only one earthing system that was very far away from these units. So assuming that that path has the highest resistance, it means that all of these customers are compromised. Again, another thing that we discovered is that all of these units have been bundled together and they are supplied with that earthing connection. That is very dangerous, if you may ask me. Now, for this kind of setup, we assume that there is a ground-mounted transformer that is a three-phase. From that incidence, we are able to tell that this house has the fuses for these individual phases. It also has the switches that will switch these phases. Top boss, we have the first phase, second, and the third. And in the same cable, we have the neutral supply. Remember, we have always insisted that the neutral acts as a return path for electricity to complete a circuit so that the appliances in the home can perfectly work. With my colleague Margaret, we were able to zero in on this earth pit. Top boss, you wouldn't believe there was no earth rod at this point. How was the earthing achieved? Each and every unit that you see here was also terminated at this point. But again, remember, this cable has a metallic sheath. Now, what was happening? This metallic sheath was acting as the earth or the ground. Now, this termination was connected to all of these conductors serving as earth connection. All right. In your region, top boss, is that acceptable? Or what is the code when it comes to electrical installation? Remember, each and every house that you see here has a meter box. In my opinion, each and every house could have their own earth pit, inspection pit for earthing, and earth rod or earth mat or whatever method, but each and every house should have an independent earth connection. Now, here is the elephant in the room. This is the only earth thing that all of these customers rely on. And remember, this is the cable that will transmit any electrical charges, or what we say harmful electric current, all the way from this point that is also terminated with an insulation tape, and it has to travel all the way to this point. My question yesterday was this: what if this point here is compromised and is broken? What happens to the customers? It means that all of these customers are at risk of an electric shock because there is no safer path of these stray charges to the ground. Remember, earthing is the provision of a safer, easiest route of an electric current all the way to the earth. My top boss, did you know that an electrical installation in a home is supposed to supply electricity, but another important factor is supposed to provide electrical safety for the people that are dwelling in there. If the earth connection that is supposed to be a safety point, especially against electrical hazards such as an electric shock, is compromised, it means that the dwellers will definitely experience a lot of issues such as an electric shock. Now, a home was not meant to receive electrical shocks, but it was meant to be very safe, or a safe haven for the dwellers that are there. Today we are going to discuss about a real life scenario where we were able to experience a customer being exposed to a lot of electric shock, and how we recommended a solution for the customer. And if she implements that, then she will continue to enjoy electricity supply that is very, very safe. Now, if this is compromised, what does that leave the customer with? It means that they are exposed. In case a certain appliance or a certain circuit has these stray charges, they will be pending on that metallic part of that appliance. In case the customer touches the metallic part, definitely they will discharge those charges to their body. Now, what this leads to is burning of the skin, which could definitely lead to serious injuries. Another issue is a cardiac arrest, or in short, an electrocution that could lead to death. That is what we were able to observe. Now, what did we advise the customer? Because the customer was periodically receiving an electric shock in her home, we suspected that this earthing system is failed. And to make another important point, this earthing point is far away. So, like we always say, electricity prefers the shortest and the easiest distance. Assuming there is a charge in house number 25, an electric shock, assuming this customer has products, appliances, gadgets that have leakages, that means that it will travel all the way to this point. And because the customer is near to this connection here, they will definitely prefer to travel to this point. At that particular instance, they will definitely get to that customer who is interacting with a metallic electrical appliance, and the charges will discharge to their body, causing an electric shock. Now, the other reason is this: if this earth connection, and especially the termination, because it is insulated by an insulation tape, is compromised, number one, by oxidation, whereby we have aluminium and copper. Our advice was that the customer has to come up with the earth connection. That means an earth rod, and not even 1, 2, or even 3, until we get the values that are below 5 ohms, to ensure that the earth resistance is very, very low. In that case, connect the customer, and only the customer. One earth connection for one person or one household, and therefore disconnect her from this community earthing and have the earth rod solely for her household. And that is the only way we can achieve safety in her home. Remember, as per the consumer unit video that you see here, this house does not have an RCCB. An RCCB protects the household against any electric shock. In case it detects that someone is receiving an electric shock, it simply trip, disconnecting the entire power supply and therefore saving the person that is on the receiving end. I just had to use the receiving end right there. Right, so my top boss, that is as per our observation, and we were able to write a report and advise the customer accordingly. That is our verdict together with engineer Margaret on the ground. Top boss, let me know in the comment section, what are other faults that you have observed in this electrical installation? And if you are the one called by the customer, what would you advise this customer to do? Thank you so much, my top boss, for watching the video up to this point. I really do appreciate you as always. If you want to watch the video I've done on consumer unit wiring step by step, check the video right here. My name is John Gatehi, and this is Top Heights Electricals and Electricians.